What if women had better health care?
What if we could know when was the best time for us to have a baby? What if we did not take 10 years to diagnose endometriosis? What if women's health was as advanced as space exploration? It will take more than dreaming. It will take science coming together with capital and execution.
Join Athena Dow in making this happen.
Discover
Projects in ReproTech, fertility, and AI.
1 hour, 1 demo day.
Hello, everybody, and thank you for joining us today on an amazing interview with Dr. Paula Amato and author Marina Gerner. We reused our demo day video because it was so amazing to remind everybody of how important it is to fund women's health research, to push the field forward, and to learn more about it. First of all, I'm going to do a little presentation to remind everybody of the work we do as the leading decentralized organization funding women's health research. We like to say that we'll be building the next biofrontier in women's health as a novel mechanism of funding. Oh, my presentation is not going forward. So what do? We develop scientific assets in women's health. We do scientific due diligence, tokenize and fund research with the biggest translational potential, support lab spinouts, and build an end-to-end ecosystem at the intersection of academia, biotech, and femtech. Today, we have reviewed more than 400 scientific projects, have had 5 funding cohorts, have deployed over $1.5 billion in deal flow assets, funded 6 labs, 3 preprints, 2 startups. Our scientific team includes people as research fellows, postdoctoral research, molecular biologists, entrepreneurs, MDs, PhD candidates, and many other life sciences expertise. Our team affiliations include people that are at Harvard, Oxford, Yale, past and former Stanford students, and people that are in industry. We've been featured in many publications on the work we've done funding translational research in women's health or advocacy, and how we use novel funding mechanisms to do so. One of the things where we're very focused at the moment is pushing our translational developmental pipeline. We have a small molecule for diminished ovarian reserve. It was one of our first funded scientific projects, and this is now in later stages with positive in vivo data. Another exciting program for us is with Gero AI and Dr. Peter Fedichev. We have a menopause for drug discovery program that we're developing with them. And third or not last and not least is our first spin-out that we supported with Dr. Joshua Johnson and the scientific founding team, now headed by Dr. Nicholas Gentry, which is already taking in some of the patients that are trying to figure out how to predict menopause. Not last and not least, we have an end-to-end network and our field building in women's health. We have 30,005 members worldwide, which includes researchers, founders, technologists, investors, and women. We've done about 80 community in-person events, 25 student fellowships, and 2 in-person scientific meetings. And doing this event today with Dr. Paula Amato and author Marina Gerner is part of the advocacy and some of the work we like to do to get more women interested in the scientific discovery part of things, as well as highlight the importance of these technologies coming to life. Without much ado, I'll read the biographies for both these amazing women, and we'll get into the Q&A by Marina Gerner with Dr. Paula Amato. Dr. Paula Amato is a professor of Obstetrics and Gynaecology at the OHSU School of Medicine and immediate past president of the American Society of Reproductive Medicine. More recently, Dr. Amato joined the team of Preventive as an advisor. They're an organization that is looking to do rigorous research into the safety of embryo editing for preventive disease. Marina Gerner is an award-winning journalist, columnist, and author of the wonderful book, The Vagina Business, the innovative breakthroughs that could change everything in women's health. Her work has been published in The Economist, Wall Street Journal, The Times, Financial Times, The Guardian, and Wired, pretty much everywhere. And I just realized that it's been a while since I've done a seminar because I'm making a lot of mistakes. Just a little quick roundup of how we're going to do this. There's going to be a 30-minute interview between Marina Gerner and Dr. Paula Amato. Then we're going to leave 10-minute question period. Please ask your questions on the chat or send them to us if you are on our community on Discord or on Twitter, and we'll try to get to all of them. I hope you enjoy this time, this privileged time that we have with the Dr. Paula Amato, who not only is a researcher, but is also at a hospital helping women conceive. Thank you so much for this, and enjoy this conversation.
Thank you, Laura. Hi, Marina.
Hi, Paula. Thank you so much for the wonderful introduction, Laura. I'm so excited to have this conversation with Dr. Amato. I think many of us were excited when these news stories came out on the BBC and CNN saying that scientists have had this incredible breakthrough using DNA from skin cells to create human eggs that were fertilized by sperm and then developed into early stage embryos. And it seems so futuristic and a little bit sci-fi to us. So I'd love to hear from you, one of the scientists behind this breakthrough, you know, how this happened, what led up to it, what the future looks like, and what the promise is of in vitro gametogenesis. I hope I pronounced this correctly, and why we need it. And, you know, please tell us everything about your recent paper.
Okay. Well, thank you, Marina. The first thing I'll say is that the coverage, I would say, was a little hyped up compared to what I would say the significance of the research is still a very preliminary step. So I want to say that at the outset. I think we're many years, if not a decade away from being able to use this technology clinically. But nevertheless, there's been a lot of interest in IVG, or in vitro gametogenesis. And what it is, for people who might not be totally familiar with it, is trying to make gametes, eggs or sperm, from somatic cells, like a skin cell, for example. People may know that women are born with a finite number of eggs, and then eventually women run out of eggs at the time of menopause, but fertility starts to decline well before menopause. Men make sperm throughout their life, but there are some men who are born without sperm or stop making sperm for various reasons. So the promise of this technology is primarily for older women who may desire genetically related children but have run out of eggs, or women, for example, who have undergone cancer therapy that's affected their fertility, or similarly, men who are either born without sperm or develop some condition where they no longer are able to make sperm. That would be the primary category of people that would access this technology if it came to be. The other group would be same-sex couples. So right now, a same-sex female couple typically has to use a sperm donor to have a child, and a male same-sex couple has to use an egg donor as well as a gestational carrier to have a child. But this technology would allow potentially for two partners in a same-sex relationship to have a child that's genetically related to both partners. So those two categories of patients would be the primary users of something like this.
Yeah, I mean, those are very, very important categories, of course. And it's really interesting that you said some of the news was overhyped, and that's such a typically academic thing to say. I love it. But I think everybody here is very excited about this development. And can you tell us a bit more about the particular paper that you published, and, you know, what led up to the paper, and what was the moment? And I know research takes many, many years, of course. What was the moment when you and your team felt like you had something there, you had a breakthrough?
Right. Well, thank you for that question. That's a very important point. You know, research does involve teams of people from various disciplines, and I'm only one contributor to this research, and my collaborator, Dr. Shukrat Talipov, and Dr. Marty Gutierrez, who's the first author on the paper, she did, and her colleagues did most of the work, but we all work together, of course. Let's start off with, there are two main approaches to IVG. The more traditional one, I would say, that people have been working on for much longer, is to try and reprogram a somatic cell to a gamete. So take a skin cell, for example, and try and reprogram that to a stem cell. And as you know, stem cells can become any type of cell in our body, including gametes. So then try and induce that stem cell to differentiate into an oocyte or sperm. Our approach was slightly different in that we also started with the nucleus from a skin cell, but instead of sort of reprogramming that somatic cell to try and make an embryonic stem cell or other type of iPS stem cell, we took the nucleus and put it in a donor egg that's had its nucleus removed. And then tried to...
And the nucleus, just to interrupt very briefly, that's like the ingredient, the genetic information, the ingredients
exactly.
of the cell.
Yes. Exactly. The nucleus is what carries the DNA, and the DNA codes for all our traits. Problem is, a skin cell nucleus is what we call diploid, or has two sets of chromosomes. And in order, our eggs and sperm have just one set of chromosomes, because then they combine to make two. So we had to kind of figure out a way to try and get that somatic cell nuclear transfer. That's the name of that procedure, where you take a somatic cell nucleus and put it into an egg that's had its nucleus removed. Try and get that SCNT egg now to extrude half its chromosome. So we were able to activate that egg. It actually did extrude approximately half of its chromosomes, and then we were able to fertilize that egg and now create what we call an embryo, and culture that embryo in a petri dish for a few days till the blastocyst stage. That's about 5 days after fertilization, which is great. The only issue, which is a big one, is when we analyzed those embryos, most of them had an abnormal combination or abnormal number of chromosomes. So that's why I say it's somewhat preliminary. We still need to figure out how to get rid of the exact 23 chromosomes that we want to get rid of before the egg is fertilized. I would say there wasn't like an aha moment necessarily. We were able to do this in mice initially. So we had another paper published last year, which interestingly didn't make a whole lot of media, didn't get a whole lot of media attention, but same thing in mice. And in that paper, we actually have live mice. So we think it works. And usually when things work in mice, eventually we're able to make them work in humans, but of course humans aren't mice, and so there's probably a lot of differences, and it might take a while. So it's, I would say, an alternative approach to the iPS cell-induced pluripotent stem cell approach. It's too early, in my opinion, to say which of these two approaches is going to be most successful. Maybe it's some combination of the two, but in any case, I think all the groups working in this area are learning from each other, and this complicated process that eventually I think we'll get there, but I think will take probably many years.
That's really fascinating. So if I understood it correctly, the main breakthrough is in that the cell managed to discard half of its DNA.
Yeah.
That is basically the
yes. And we got rid of the whole, when you reprogram a somatic cell in culture, that could take months and years. So the advantage of this is that it's pretty instantaneous. It's a lot quicker. And, we have a concern, many people have a concern that while you're culturing these somatic cells, trying to reprogram them, all kinds of genetic and epigenetic abnormalities might be occurring during that time. So that could be deleterious to a resulting child or infant. So we do think our approach has some advantages, but of course it has other disadvantages.
And you said the majority of the blastocysts were abnormal or not viable. Is that true for all of them, or?
Yes, all of them. Yes. So none of the embryos would have been transferable into a woman's uterus, because
even though 5 days, is not far off from when it theoretically would be transferred, right?
Yeah. Obviously the ones that had more serious chromosomal abnormalities never even made it to that stage. But maybe if they were missing just 1 or 2 chromosomes, or had the wrong combination of 1 or 2 chromosomes, they could develop quite further. But we wouldn't expect that embryo to continue in utero and result in a healthy baby. So in terms of the next step for this research, we'd like to figure out how we can make that chromosome segregation happen more faithfully, so that, you know, we have 23 sets of chromosomes. We want one pair from chromosome 1, one from chromosome 2, one chromosome 3 to be extruded, and to leave the correct 23 chromosomes in that SCD egg, so that when we combine it with the chromosomes from the sperm, it would result in a normal chromosome complement in the embryo.
Yeah, that makes a lot of sense. And could this process potentially be applied to sperm too?
It could, theoretically. The people have tried also to do in vitro spermatogenesis. It turns out that it's technically a little more challenging, actually. But in theory, we have some ideas about how you could take a somatic cell from someone without sperm, put it in an egg, and do a similar type of process to end up with, you know, the chromosome set from the person providing the somatic cell, and one chromosome set from the person providing the egg, assuming the partner has an egg.
I guess the egg is much bigger.
Yes, for sure.
That is one of the advantages.
Yes. So technically, making in vitro spermatogenesis is technically much more challenging. But it's also, there's a bit of lesser need, because, as I said, most men continue to make sperm till they die, basically, whereas, you know, age-related infertility is primarily a female phenomenon.
Yes, of course, absolutely. And how long? I know you mentioned briefly that it might take a decade, which to me doesn't actually sound that long, given, you know, the shift it could create. So how long does it actually take for a proof of concept study like this to become a reality? And, you know, what is the likelihood? And maybe that's not a very fair question, but what's the likelihood of it succeeding?
Yeah, hard to estimate, of course. I think maybe a decade is perhaps somewhat conservative, you know, when you consider what would need to happen. So first we would need to, like, work out all the, you know, potential abnormalities, work them all out in a human in vitro embryo model, like we're doing. But even when we get to the point where, yep, this embryo looks like we could transfer it, we probably wouldn't just transfer it into a human uterus. We'd probably go do a similar experiment in a non-human primate, such as like monkey model or marmoset or some other animal model that's closer to human than mice. Let's make sure it's safe in that model. And then only then, if it turns out to be safe, and probably have to follow multiple generations of monkey as well. That's the other thing. You know, when you affect the germline, when you make changes to the germline, it's going to be inherited. Those changes are going to be inherited to multiple generations. So it's super important that we get it right, because you're not just affecting, you know, one individual, but potentially all their descendants as well. So only then would we go back and do a clinical trial where we would actually, you know, transfer that embryo into a human uterus. So, and that's just the science part. And, you know, we haven't talked yet about all the regulatory challenges and the ethical challenges. So, for example, in the United States right now, even if we were at that point, we probably could not do a clinical trial, because there are certain restrictions about what we can and cannot do with human embryos. So we would likely have to do it outside of the United States unless things change.
Where do you think would be likely?
Well, you know, there's a number of different countries that are where we could potentially do it. So most countries don't have any laws at all regarding, you know, some of this technology. There are several countries that prohibit it outright, including the US. The issue is that US has a really robust IRB system, or human subjects protection program. So I would personally rather do it in the United States, where I can ensure the safety of the patients more so than I could in perhaps a country or jurisdiction that has maybe less robust. Not to say that other countries necessarily have less robust restrictions, but I feel like I have less, control over this situation. I know the system in the U.S. pretty well. So my hope would be that, in the next 10 years, we might see some changes if the technology is promising enough and there's enough demand from patients and there's enough assurances about safety and that type of thing, that perhaps some of the laws that prohibit this research being done in the US would change.
Yes, I guess it's very much a political question as well, with the idea of personhood and so on. So it's very much a quickly evolving situation. That's really interesting. And which other ethical issues could result from, IVG becoming a viable possibility?
Yeah, there are a number of them, and I think they're very important. I think it's important to be talking about them and to engage the various stakeholders involved, including patients. The biggest one for me is safety, basically. If it's not safe, then of course we shouldn't be doing it. But beyond that, there are issues about like who has access to this technology. Will it be only available to, people, wealthy people in certain countries and that type of thing? And that's not unique necessarily to this technology. A lot of medical technology has that issue, that it's not equitably, the access isn't equitable. Then there are some people who have issues with creating embryos for research and discarding embryos. So there are people who have religious and moral issues with that, which I totally respect. But, I think where I draw the line on that is trying to impose those beliefs on other people, because obviously reasonable people can disagree about the moral status of the embryo. And that drives a lot of the restrictions and the laws, and it's very political, as you said. So sometimes difficult to kind of separate that from the actual kind of science. And then there are issues. If you could make eggs very easily, perhaps hundreds of eggs, and then there's perhaps hundreds or thousands of embryos, then that opens up the possibility for embryo screening, which we're already starting to see. And we do embryo screening to some degree. And when we do IVF, you can screen for chromosomal abnormalities, you can screen for single gene disorders, and more recently, you can screen for what we call polygenic diseases. One of the issues with PGTP, as it's called, is that we don't think the utility is very high right now, because most women, when they do IVF, they get a finite number of eggs, there's a finite number of embryos, and probably not going to be a huge difference in some of these risk scores, amongst 2 or 3 embryos. But if all of a sudden you had 100 embryos, then there might be quite a variation in the risk scores. So that would make that technology, the utility of that technology would increase. And that is also controversial, because while people might want to screen to prevent diseases, there's also some people who might advocate screening for non-medical traits, things like IQ, etc., which, it's not clear that you could even do that, but if you could, then that raises a whole nother sort of ethical issues. Should we be using this technology to screen for non-medical traits? And to take it one step further, if gene editing, embryo editing, becomes the reality, then you could potentially modify some of these genes, maybe many genes in an embryo, before you transfer it. So yes, it's rich with ethical issues, and I think we need to be talking about them. I think it's not likely that we'll reach any kind of consensus on some of these, but the science is not going to wait. It's basically moving forward. So I don't think, you hear sometimes people call for moratoriums or bans on this type of research. I don't think they work. I don't think they're effective. the science, it's just going to drive the science underground. Somebody's going to do it somewhere. And, I think the science is a science. It's going to move forward. And we need to be talking about these things because we can't ignore them, and they're real issues.
Yes, I agree. I really like that quote. The science is not going to wait. I often talk about how you can't undo science, for better or worse. And I absolutely agree. I would rather it was done in a regulatory, responsible framework. And that's why it's so important to be having conversations like this one, and to just be aware of the multiple implications. I hadn't thought of, I hadn't imagined having hundreds of eggs or thousands of eggs and what that would mean. But of course, you can do all sorts of analysis. And you mentioned IQ, which is fascinating. I was thinking gender immediately. It took me to gender and eye color, things like that, which
we can already do gender, and we do that.
Yes, right, exactly. Which,
or sex, more correctly.
Yes, exactly, sex. Yes, exactly. So that leads us to the idea of designer babies and so on. And if somebody had easy access to hundreds of eggs, there have already been stories of a billionaire who's created a baby project for himself, where he has, in the US, bought eggs from various donors and hired surrogates to sort of have dozens and dozens of children. So it does raise all of these issues, and it's very much interconnected with the idea of access and equitable access.
For sure.
But on the other hand, I was also thinking a more optimistic or positive scenario would be to think, what would the world look like if we removed the biological clock?
Yeah.
What I'm only beginning to imagine.
Yeah.
Do you have any thoughts on that?
Yeah, I have lots of thoughts. Yeah, it's an interesting question. I feel like we're already able to kind of shift a woman's reproductive window a little bit. Egg freezing is pretty common, not super common, but it's much more common these days. And, if a young woman freezes her eggs, she could potentially have children in her 40s, so instead of, 20s and 30s. So, and, as we all know, women are they're participating in the workforce, pursuing education, etc. They're having children later. They're having fewer children. There's a variety of reasons for that. But certainly if you start late, you're likely to have fewer children for sure, because eventually, you're going to age out. When I think about that, I think, oh, that's great, because it gives women more options. But then you still have to carry that pregnancy. So I'm not necessarily advocating for people to have children in their 50s, for example, because then all the risks of pregnancy increase, like hypertension, diabetes, hemorrhage, everything is much more common as women get older. But I think a few year shift in the reproductive window, I think, is actually quite beneficial. And we don't have to wait for IVG necessarily, but because we have egg freezing now. But not everybody had the opportunity to do egg freezing. Not everybody can access egg freezing, even if it's available. So IVG definitely will still play a role, I think, even if egg freezing becomes more ubiquitous. An interesting thought experiment that I sometimes do is, what if it were like the men who went through menopause and not the women? What would that look like? If women remain fertile for their entire life, but men, aged out after a while. I just think it's fascinating to imagine. I don't read a lot of sci-fi, but anybody out there who's listening who's like a writer, like I would love to read that story, what that looks like. So, it's interesting to think about that possibility. And then, the ovaries produce eggs, which are important for fertility, but the ovaries also produce hormones, and I think Laura alluded to this. One of the companies that Athena Dow is supporting is trying to basically extend your reproductive lifespan. And those hormones that the ovaries produce we think are important for other health reasons, perhaps cardiovascular health and neurological health and that type of thing. Now, of course, you can take hormones to try and mitigate some of the effects of menopause. So, it's not clear that just extending the life of an ovary would necessarily be more beneficial. But it's interesting, we're always focused on fertility, but hormones are like super important. And women, as you may know, up to 100 years ago, the average lifespan of a woman was 50. So like menopause wasn't even a thing because women died before they even hit menopause. Now we're living on average into our 80s. So now it's like a third of our lives in menopause. And it's a new thing. And we're actually one of the very few species who goes through menopause. I think it's only humans and some species of whales. It's like fascinating to me. Like, why is that? But this is like a fairly new phenomenon that we have to, think about living a third of our lives in menopause. And
yes.
Yeah.
Absolutely. Well, I've heard of the grandparents, theory, and that is the reason for why we have menopause. But I would love to read the sci-fi book that you mentioned.
Yes, yes. I think it would have all kinds of societal implications.
Yeah, absolutely. And I think it's so important, the point you mentioned about even if you freeze your eggs, because I think that's something people don't often talk about or think about, that you still have to carry the pregnancy. And it's certainly harder to carry a pregnancy, at a more advanced age. And also, just speaking for myself right now, I had a child 1.5 years ago, and I'm 37. And those sleepless nights, it's killing me. I'm just, so sleep deprived. It is hard.
It is hard. Yeah. And I don't want to give the impression either that, sometimes people will say, if we encourage, egg freezing, and encourage women to have children later, it's not necessarily ideal. I think in addition, we should be making it easier for women to have children in their 20s and 30s, if that's what they want to do. So there's a number of barriers that are more societal and economic to why that's not happening as much anymore. But we should totally, things like affordable housing, subsidized daycare, and that type of thing to help women, not just women, but women and families have children at a younger age.
Exactly. That's sort of the fear that, or the criticism that people often voice, is to say, well, companies are giving women these benefits to go and freeze their eggs instead of providing shared parental leave and parental leave policies, childcare support, and so on. So it's absolutely such a multifaceted societal issue that is deeply intertwined with everything around it.
Right. One other point I'd like to make is if this technology became clinically available, it might actually change how we do IVF, right? Even for people who have eggs. If you can now just take a skin biopsy and make a bunch of eggs, why would you do like ovarian stimulation and egg retrieval and all the things we have to do now? You would totally change how we practice IVF, and it would make it in some ways less, assuming it's safe, again, less risky for the female partner who's currently having to undergo stimulation egg retrieval to produce an egg to create an embryo. So although the focus obviously in people who don't have eggs, if it became widely available and was just as effective and safe, use it for everybody.
Yeah, that's a really good point. So it would completely change IVF and egg freezing and pretty much everything.
Pretty much everything. It would really be revolutionary if you got to that point. Hey, Laura.
Hey, so I'm coming back. This is, we could go here for a long time, but we want to keep it at 45 minutes, and I really want to make sure that we get to the questions. I am also very happy to let everybody know that we have almost 200 people watching. So obviously there's a lot of interest in this subject, specifically because it's the future. We have the fertility crisis. Obviously, anything that has to do with reproductive technologies, a lot of people have a lot of very strong opinions about it. I'm going to go with my first question for myself. Paula, women today, if they were curious about this technology to use it in the future, let's say, what could I do? Could I freeze my stem cells right now so that you can use them in 10 years, see if this technology works? Because I already did freeze my stem cells.
I would say if you want to have children, you don't have children yet, and you're in your early to mid 30s, definitely freeze your eggs, because that we know works. It's not a guarantee and it's not 100%, but it wouldn't there's no reason to necessarily freeze your skin or stem cells. I mean, theoretically, I don't think there's any good reason. So do something that you know works, and then, if this technology came to fruition, then you would still be a candidate, because you'd still have skin presumably at that point, or some other somatic cell that we could use.
Okay, well, I just wanted to ask something like, when you talk about people that want to optimize for the future, or things that they say even in longevity, right? Oh, do this, and maybe when in the future these technologies are available, you will be a candidate.
Yeah.
So a woman curious about this, is it like a route to take if the egg freezing situation didn't happen or didn't go well already, or I guess an alternative? That's why I asked, but you're right.
Yes.
Start with the basic concepts. So our first question was, could future stem cell technologies reprogram stem cells into functional ovarian tissue so young cancer survivors without prior fertility preservation can restore function instead of using HRT?
So if I understand the question, could we somehow like maybe transplant these eggs back in the body to produce hormones, or?
I guess to bring back ovarian function, but that we can already do. When you take a graft of the ovary, you cryopreserve it and put it back post chemotherapy for women that had gone through cancer treatment, correct?
Right.
Like there's already that is available.
Right. I would say the more common situation is to freeze eggs, and then use those eggs for fertility, and then just take hormones if the patient is a candidate. Certain people can't take hormones to deal with the menopausal symptoms and the bone loss that can occur after menopause. So yeah, we do have sort of technology now that can mitigate those risks. Certainly if IVG became available, it would be another way to at least address the fertility part.
Yes, I guess the restore function means ovarian function. So it would have been what you mentioned. But I know that one of the big things that people are discussing now for extending ovarian life, or not discussing, but to do this procedure, even in our demo day, Profam is a company that does this as a selective procedure you go to, which is an elective procedure you go to, which is cryopreserve your ovarian tissue, so that when you're in your mid 40s, 50, you bring back that tissue and your ovary regenerates to that younger self. Yeah. So it's like the new generation of, instead of doing Botox and facelifts, you like do the ovarian lift.
Yeah.
Anyway, that's another panel. That's another chat.
For sure.
Next question from Trisha Perez is, what are ways we can participate or become involved in some of these ethical conversations? And Paula, you mentioned we need to have these conversations. Where can people get engaged?
Yeah, that's a very good question, because I do think that lawmakers in particular need to hear from the public. There isn't an obvious way to get engaged, but there's something called like the Global Conservatory, forget the exact name, but I'll send it to Laura and then maybe she can post it somewhere. But there are people who are talking about, there's various panels. The National Academy of Sciences had a workshop on IVG where there were ethicists involved. So those proceedings are available online. Certainly, write to your local member, I know this is international, but your local representatives, especially like in the US, if you are interested in having some of these laws changed that restrict some of this research, then that's another way to engage politically. So yeah, just look online on social. Follow me. I usually post things that have anything to do with ReproTech. So.
As a little just call to action, if you subscribe to our newsletter, we try to follow a lot of these news. Obviously, and when we say we do field building, is because we try to bring these researchers and scientists in events like this to discuss this tech and for people to learn more about them. And then, yes, get them to engage more and potentially, as Dr. Paula Amato said, advocate for these technologies to come to light with you being part of the conversation, and specifically women, because this is really going to impact our lives in the future. We have Dr. Jonathan Anomaly, which I know Paula knows from her side. He mentioned something and asked a question. So I'll read what he mentioned, and also I'll get his question, and then we'll go to Ekaterina's question. Just as a side note, I've already asked Jonathan to be a guest speaker in the new year to talk about polygenic embryo screening. So hopefully we'll settle on a date, and we're going to have him also talking about this in a future session. He says that our PGSCs for many diseases exceed many quote-unquote modern medical miracles. E.g., with 3 embryos and history of heart disease, screening embryos is generally as effective as a statin. Do you have a comment on this, Paul?
So the point is that even with a few embryos, there is utility in doing PGTP. Yeah, I think so. I've seen some of that data, and I think that's probably true. I think obviously the more eggs and more embryos you have, even more the utility is even greater. Yeah. So I know PGTP is somewhat controversial, and currently some of the major medical organizations don't recommend that we offer it routinely. But in my opinion, I think reproductive autonomy should prevail when, especially if the science is not entirely clear. It doesn't mean that that the science is clear that it's not effective or that the utility is low. So I think it should be up to the patient. It's my personal opinion, not the opinion of the American Society for Reproductive Medicine or anything.
Well, that's where the advocacy comes for people, trying to be more of a patient-centric advocacy. His question on IVG is, what is the most effective way to speed up research? Is it capital or lighter regulation on research?
I think both are important. That's a good question. I think the funding, at least in the US where I work, is restricted. So the NIH, National Institute of Health, where most academics get their research funding from, does not allow funding of any projects that involve destruction of human embryos. So we're not eligible for that type of funding. That's why, we need private funding, and that could come from philanthropy, but also more recently, as we're seeing with gene editing, for example, there's investors that are willing to provide funding. So, I think it has to come from somewhere because this research is very expensive. So, so funding is an issue, and then the regulations, they're an issue. When we get to the clinical trial stage, it's going to be an issue in the US. Like I said, one approach is to go somewhere else and do it. I would, personally would rather do it in the US and change the regulations if possible. There are also maybe workarounds to the current regulations. So the current FDA restriction is that they can't consider any clinical trial that has to do with genetic modification of a human embryo. That's the language. But really, you could argue with IVG, you're not really genetically modifying the embryo necessarily. You're genetically modifying the egg. So if the egg is now the product and not the embryo, and I know it's weird to talk about embryos as products, but biologically, for FDA purposes, then there is a potential workaround, but it's not clear. And plus, we have a new administration, so who knows how they feel about it.
It's going to be an interesting decade.
Yeah.
Ekaterina Malinina is asking, there are 2 questions. The first one being, what's the major bottleneck in fertility span extension for now?
One more time, sorry.
What is the major bottleneck in fertility? I guess she means fertility span extension for now. So, extending a reproductive life.
Yeah. The biggest issue is that we have nothing that increases egg number or egg quality. Like IVF is the most effective treatment we have for most cases of infertility, but even IVF, if you look at success rates, is age dependent, right? Maternal age dependent, so that the success rates decrease. So we really, if we could somehow figure out a way to improve egg quality and or freeze eggs, which we have now. Maybe the goal should be really to focus on access to this technology that we already have. But I would say that is probably the biggest barrier. I don't know, Marina, do you have thoughts on this question?
Yes, I agree. Egg quality seems to be the holy grail, and if you could somehow help the egg continue making that division accurately, right, with more advanced stages, then you could address this issue in a very specific way. But
Yeah.
I think you're absolutely right that even the current technologies that we already have, like IVF and egg freezing, they're not accessible to so many people. And there needs to be a change in how that's delivered and how that's communicated.
Yeah.
And also in how well it works. Those techniques still need to be improved.
Right. Another technology we're working on is called mitochondrial replacement therapy, which is where you take the nucleus from an older egg and put it into a younger egg that's had its nucleus removed. So kind of similar to what we're talking about, but to try and improve the egg quality of that older egg by leveraging the young cytoplasm. It's a hypothesis at this point. There are people doing it in different countries, not allowed again in the US. It's allowed in the UK and Australia, but only to prevent mitochondrial disease transmission. But me and my research team, we have a theory that we think this might help also with age-related infertility. So we are planning a clinical trial, and unfortunately we have to do it outside of the US. So stay tuned for that, and I'll send Laura the information she can disseminate.
This is a good reminder for everybody to join our newsletter, because we do share all this information. Try to obviously get not only the research community, biotech, and academic industry informed, and everything that matters to women's health and reproductive technologies, but also women themselves. I want to say that one thing that we say at Athena Dow that's always the biggest bottleneck is more research and more funding into this research, because the reason we don't know more about getting good eggs or ovarian function of all of this is because we haven't spent the capital to do this research. So always more research and more funding into it.
Yeah, and to that point, Marina's book, if you haven't read it, Vagina, that's the whole premise of the book. Marina,
Yes.
You want to say more about your book?
Yes, absolutely. My book is all about women's health innovation, and I've interviewed 100 pioneers across the world, across 15 countries, to show people what is possible if we do fund these things, and if we do the research, and if we put a concerted effort into women's health innovation. And when I was doing my research, I didn't know you, Paula, but maybe for the next book.
For the next one.
Next edition, yes.
And one more question from Ekaterina, and I think this one, I assume she might be in biology or life sciences, or is curious in general, but what are the best and most useful options to participate in ReproTech for those who are not? I know she's the opposite of that. She wants to be involved, but she's not a biologist or a clinician. How do women like her can get involved?
Yeah, there's always a need for non-scientists as well on the advocacy side, on education side. I think the more we talk about these things, I think the more helpful it is. So there's a variety of different companies that in the space now, like PGTP companies, gene editing companies, IVG companies. So might be worth keeping an eye on some of those. Advocacy, we mentioned, education. Marina, do you have other thoughts? How to get involved in ReproTech?
You are muted.
Oh, sorry. My son was shouting in the background, so I muted myself. But through communities like Athena Dow and other communities that focus on, sometimes they call themselves femtech communities, sometimes just women's health innovation communities. I think those are a really good starting point, and then you can see what companies are out there, what jobs are out there, what research projects are out there. Because once you start looking into it, it's a fascinating world to be part of.
Yeah. For sure.
Yeah, it's super fun to be at the start. I mean, it's been years of this research, but it also feels like it's just at this new inflection point. One last question, and this is from Victoria in particular to IVG. Outside of the funding, what are other gaps in the research that are preventing, I guess that would make accelerate IVG, or that maybe doesn't make it go faster?
Yeah.
Is it a scientific issue, just a funding one, or anything else?
No, there are actually a lot of scientific issues. Go back to my first comment. This is like very preliminary at this point. So in addition to at least for our approach, in addition to the chromosome segregation issue, we haven't even begun to address things like recombination, where, exchange of DNA between different alleles, imprinting, that's another thing. So there's a lot that still needs to be kind of figured out. Whether we're talking about reprogramming or SCNT, there's a lot of scientific questions that still remain. I think they're addressable. I always think, the body does this, right? Like, we all start from stem cells, and eventually, these cells differentiate. So the body knows how to do this, so we can figure it out. It just might take a while. But yes, there are a lot of scientific challenges still, in addition to the funding and regulatory things we brought up.
Well, we're going to let you get back to figuring out those scientific challenges. Paula, thank you so much for being here with us today. Marina as well. I said to Marina, please you do this interview, because I'll go very geeky on the science, and I really want women to get more interested. And Marina is a great communicator and a writer. Oh. She asks the questions that that elicit the responses that probably women want to hear more about, and people in general. Thank you so much again for being with us, and just wanted to let people know that we are dropping some links for some of the upcoming events that we have for Athena DAO. If you're in London, we are sponsors for the British Fertility Society conference that's going on next week for Reproductive Frontiers. It's happening and on the Thursday and Friday, and it's a great academic conference. So if you're in the field in the UK, I highly suggest you try to attend. The link is on the chat. We're also having a menopause event in December, on December 9th, similar to this, with other researchers in the field. And as I mentioned, hopefully in the new year, we'll have Dr. Jonathan Anomaly and another guest from Heresight, another guest here to do something similar to what we did with Dr. Paula Amato and author Marina Gerner. Again, a reminder that part of our work is a lot of advocacy and trying to get these conversations going, so people are informed not only about the science, but some of the more interesting research that is going on and why it's important to our future and our lives today. With that said, have a great weekend. And all the links are on the chat. And thank you so much for your time again. If there's anything like a call to action that you want to do, Paula and Marina, I'm going to let you also do this now.
Thank you very much, Laura. And thank you, Marina. It was a pleasure to participate. Thanks to the listeners.
Yeah, thank you very much for organizing this conversation. I feel like I've briefly traveled to the future, and it's super fascinating. And I think something we all can do is, start a conversation with someone else about this and just spread the conversation.
Yeah,
that's a great takeaway. Bye now, and thanks again.
Thank you.
Thank you.
Bye-bye.
Take care. Bye.
What if women had better health care?
What if we could know when was the best time for us to have a baby? What if we did not take 10 years to diagnose endometriosis? What if women's health was as advanced as space exploration? It will take more than dreaming. It will take science coming together with capital and execution.
Join Athena DAO in making this happen.
Discover
projects in ReproTech, fertility, and AI.
1 hour, 1 demo day.